Hello and welcome to episode 9, Importance of Brain-Computer Interface. To understand this emerging nexus of technology as well as its application in defense, space, and other sectors, we have today with us Ms. Sonal Baberwal. Hi Sonal, welcome to the podcast.
Hi, Omkar. It's a pleasure to be here. Thanks for inviting me.
Likewise, thank you very much for joining us. So as we'll be taking a deep dive into this topic, can you please provide us a brief outlook of your journey in this area of interdisciplinary research?
Absolutely. So, hello, everyone. I am Sonal Baberwal. I completed my bachelor's in electronics and telecommunication engineering from India, from Sapna's College of Engineering and Technology. And then I pursued my master's in space studies from International Space University, France. And during my master's, I worked as a research scholar in Human System Integration Division Lab at NASA Ames Research Center in the lab of Fatigue Countermeasures Laboratory. And that's where I had my first EEG or like brain signals experiments. Later, I worked as a research and development engineer in Spain at VTUT. And presently, I'm a postgraduate researcher at Dublin City University and ML Labs with research focus on motor imagery-based brain-computer interface systems under supervision of Dr. Shirley Coyle and Professor Thomas Ward.
Wow, that's a quite a different journey, I would say, because you literally came from engineering background and you're now working in a branch which is also aligning highly with the medical sciences. That's really good. So yeah, we'll start with the actual part of the discussion for which we have organized this podcast, especially this episode. So what is brain-computer interface and why is it important for modern world? The reason why I'm asking this as a basic question is because we have a lot of audience which aligns with the political science, international affairs, and looking towards the technology from a policy point of view. So it is very important that such an audience also needs a definition of such a complex terms. So yeah, please feel free to let us know your thoughts on this.
Absolutely, Omkar. Initially, I would like to ask your views on what is brain-computer interface for you as someone, let's say from audience perspective.
All right. So as from my understanding, brain-computer interface is something from which you can measure the electrical signals from your brain. So that's the only definition I know for the moment.
Absolutely. So yeah, it's really possible to read your brain signals. But before diving deeper into that, what we'll do is we'll take like technical and non-technical insights together. So I'll give just like a brief history about it before we could proceed to like why it is essential. Is that okay?
Yes. Yes, definitely. Please.
Okay, perfect. So like to quote it in a technical way, brain-computer interface is a communication pathway with a proper system, like, from your brain to an interface. So as it describes, like, brain computer interface. So you have got brain signals, you have got algorithms, and then you have interface, like, the interface can be anything, like moving an exoskeleton or like, a cursor on your screen or flying drones, even that. So yeah, you kind of like measure your brain signals, you collect them, you use algorithms to decode them, and then you interface it with something external. So when it comes to sensors, they are like there are invasive and non-invasive sensors. So let's say like, when it comes to non-invasive sensors, there are chips that could be implanted in your brain. And then there are invasive sensors like electroencephalography, where you can measure your signals non-invasively. To give a much familiar example, it's just like ECG, where you monitor your heart signals, or wearing a smart device where you can actually monitor your blood glucose or other signals. In the same way, you could actually monitor your brain signals using electroencephalography. Fun fact, the traces of these signals were published way back in 1929, and the term brain computer interface was coined in 1973. And since then, the rest is history, and you could see how the field has been evolving. So coming to past definition of brain computer interface, it was more like to operate exoskeletons or spellers, and mostly used for with the cause of helping people in medical domain, with people having spinal cord injuries, or like using for stroke rehab, or people who were had like locked in syndromes. But if you see about present definitions, it's all about any sort of interface. Like you could operate any sort of interface. So to give an example would be like in a modern day world, imagine your brain signals could actually have an interface with your own mobile or like your computer.
Wow.
So that's where the present definition comes like. So again, I would like to clear a myth here.
Yeah.
The myth is that this technology can read your mind, but in reality it can only read the state of your mind.
Okay. Yeah, this is very important to be clear on. And I think
Exactly.
that's a very hardcore point, because generally I have seen a lot of people having a misconception about this concept, mainly because of a lot of science fiction movies that we see are all around. But yeah, this is very important to know that it's not about knowing what your brain is going to do or what it has done, but it's about what it is going through at the moment, right? That's what it is.
Exactly. And like looking at the paradigm shift that is happening right now, I believe that we will be overwhelmed soon with so much of usage of technology that, for instance, like let's see today's example, okay? That you almost have a second brain with you, right? Like, you have your computer where you organize your day with your calendars and Google Meets and everything. So it's like having a second brain, right? So I think as of personal use, it would be nice to have your monitoring your own brain waves that would be connected to your gadgets, and so that you don't face decision fatigue, and like small decisions could be taken on your behalf.
Yes,
And the reason
technology, yeah. Yes.
and the reason this is essential for our modern day world is like we have so much of raw data from the population. Like imagine having brain signals not just like from your self thoughts, but also the thoughts when you're interacting with different humans.
Yes. Yeah, this is the great analogy. That's what I was saying previously before you completed the answer. So just like moving a little further ahead from the definition. So as this technology has branched from the medical sciences, so can you briefly explain us what are the triggering factors that are advancing the research of such a multidisciplinary technology applications? I'm saying multidisciplinary because it's not just dealing
Mm-hmm.
with one branch, it's also dealing with computer science, a lot of psychology things as well. So yeah, please feel free to tell us like what are the triggering factors that are advancing the research in this sector.
Omkar, I really like this fact that you have used multidisciplinary perspective on this. And to answer that, I would say that this field is yet in an experimental zone. Like, for example, it is not ready to be used in activities of daily life. That's what we term it in like ADL. As I mentioned before, this technology would be traced as early as in 1970s, and for the first time it was implanted, the implanted BCI was there like in 90s. But what happens is, as much as people find this technology fascinating, the study is still conducted on a sample size. To give you an example, like when you come up with an hypothesis,
Yeah.
the subject size is only like 20 to 30 participants,
Okay.
and then you make a judgment, or like an answer to your hypothesis based on just a small sample size.
Okay.
What happens is, like, when people talk about it, like, to be honest, like what I have seen during my research and like collecting data and everything before I started like at DCU. The myth is that people feel that, maybe like, we are trying to read their brains, and sometimes people hesitate to participate in the study.
Yeah.
So I think that's the one of the challenge that, it is conducted only on like a small sample size. And then another challenge is that it takes a lot of time to set up. So whenever you are setting up this experiment where you want to collect the brain signals, it takes like almost 40 to 45 minutes to apply the gel and electrodes and everything. And then you also have to explain the entire setup to the participant. And then you also have to make them aware of like how their hand movements or like, their leg movements or their eye blinks could actually affect their signals, which is like termed as artifacts in like the medical domain. So yeah, and for them to like get used to of the experiment and get training out of it, it takes time. For example, I work in motor imagery signals, which is like imagination of your left and right hand movement instead of imagining it. And that could be actually used to operate devices like exoskeletons. So for instance, if you're thinking about left hand or if you're thinking about right hand without actually moving it requires a lot of training for the person to actually kind of generate those signals without intentionally moving it. And then translating that into results which could actually move a system. I think, yeah, these are like a lot of triggering factors that it takes a lot of time, it takes a lot of training, the setup, and like what people see this field as.
Okay, that's a pretty extensive overview. I'm pretty sure we won't be able to cover everything right now in this podcast, but definitely we'll be happy to engage into other episodes where we can possibly take out some small factors out of it and do other episodes too. So yeah, just moving forward, considering that the brain-computer interface can create plethora of opportunities for several industries, as you mentioned right now. So, what are your thoughts on its applications in space and defense? And I'm asking this question especially not only because our podcast is concentrated for space defense and security individuals, but also because you as an individual have a background in the space technology. So, yeah, please tell us your thoughts on its application in space and defense. Like briefly, the thoughts would be fine to have.
Okay, that's really nice question. So I think this technology could augment human capabilities and human computer interactions. So as per my perspective, BCIs could accelerate and simplify interactions between humans and machines in general. So it has humongous opportunities in defense and space. And also, like, some researchers have suggested, like, not just difference in space, like space is considered extreme environment. So they've suggested that BCI controlled robots could assist people in environments like coal mines. So coming to applications in space domain, I think like my concept is maybe if in future there could be a possibility of integrating this system into spacesuits, and like the concept of having a third arm for astronauts, like when they perform EVAs, so that like that could be like an assistance to them. And there could be a possibility of operating rovers using these signals. And yeah, this technology could be used to study human performance, not just in space, but as well as on the Earth.
Interesting. So I'm myself as well. I'm from the space industry. I work in the core space domain. So just out of curiosity, this one more question related to the space
Mm-hmm.
sector. So can you provide us a brief example of the recent developments of brain-computer interface in both space and defense, or either of this branch?
Actually, Omkar, I have like a lot of examples for this question. So I would like to start by quoting what Darpa suggested, like smart systems will significantly impact on how troops operate in future. To give an example of that, um, there was this case study by University of Technology Sydney where they developed a system with mixed reality smart glasses using these sensors to command a ghost robotic quadruped robot. So where there were 6 commands and 6 flickering frequencies where the robot could actually go using the brain signals. Whereas Da Vinci Lab in France, they are also using brain signals and hand gestures, of course, to control drones. And then there are other applications where, for instance, Space Application Services did a case study on potential use of brain computer interface with exoskeletons in space. And then NASA as well has used BCIs to help detect when pilots and air traffic controllers are more likely to make mistakes. And apart from that, Department of Defense has also funded a research on BCIs for hand-free control drones. So yeah, there are a lot of examples in defense and space field.
Wow, that's quite exciting. I think I really need to explore this branch very well because I have not been familiar so much. As I have never been mainly so much inclined towards biology, but I think this topic of yours really makes me much more interesting and inclined more towards biology and look to this branch not only from the space sector, but from the lens of biology to the other wide area of the industries where we can actually make use of such an applications in day-to-day life as well, not only in the industrial sector. So I think you've just covered all the industrial hotspots things that as well, which was I was supposed to ask you. So yeah, thank you for that. So just yeah, proceeding ahead, because as I mentioned, as an individual, I'm so much interested into this. But an individuals like me who are actually investing their time and efforts into this would also like to know the challenges. So yeah, this further question is about how the what challenges are being faced by BCI researchers, and from your perspective, will it be challenging to give a commercial market entry for such a technology? Because as I mentioned, like individuals like me, we of course go for opportunity, but we have to also assess what are the challenges. Without that, we cannot invest our time and efforts into something that will take lengthy stretch of time. So yeah, please feel free to put up your thoughts on this question.
Thanks, Omkar. I think the biggest challenge from my perspective is that each person generates unique brain signals. Apart from that, it's more about the gap between research and commercial market. So it's like researchers have pondered social and ethical implications and also reported that the cost of these wearable devices would range from few hundreds to $1,000, which may result in unequal access. And then apart from that, as I mentioned before, BCIs require training, which may be also a burden for users. Like not everyone would be interested to invest their time to be into these kind of trainings. And yeah, like another possible challenge could be for instance, translation of brain signals to speech by using a BCI. It could be of harm if not accurate. Like inaccurate translations might indicate legal or medical consent that the person did not intend to give. So I think the biggest challenge here is to misinterpret the signals, and also like the gap between the research and commercial market.
Okay. Yeah, this is a very important thing, because as a individual coming from the business side in the space industry, I see that the research and market gap exists everywhere. But I think especially for a complex multidisciplinary branch like brain computer interface, it's still not explored. And definitely I would love to explore that branch in the future. Yeah, as we are near, coming to the end of the podcast at the moment. So, just taking a step back, moving from science to policy back. So I would like to ask you whether, every technology application weighs in both opportunities and challenges. So from your perspective, how policymakers should look to this advancement in terms of minimizing the future threats that may occur due to BCI. Because as we have seen always, every kind of technology has a disadvantage. For example, the communication technology has definitely closed the gaps of sending the messages, but it has somewhere started, putting a stretch between the human relations. This is something we are observing in a very social ecosystem at the moment. So, from your perspective, similar to the brain, for the brain computer interface, what are the future threats that you see in this domain, and especially uh, possibly the advantages that can be taken by the adversary groups?
That's interesting, Omkar. From my perspective, I think the biggest future concern would be consent. It's like smartwatch. Like, you could use it for being better than what you were yesterday. But what if it is used to understand your state of mind without your consent? So that itself is a concern for me. If you look at opportunities, of course, it has opportunities like, helping people with disabilities. Like, for instance, if you see stroke rehabilitation, the people who use BCI systems perform better than like normal rehabilitation. Or like, like if the person gets overwhelmed, we could actually detect it. But there are challenges, like real challenges, for instance, ethical framework and security and privacy. And like these systems could be vulnerable to cyber attacks. And yeah, that is like a concern. So in terms of policy context, there could be like, some gaps and questions that could be taken into consideration. For instance, like as this technology is moving towards commercial and patient use, like will this be accessible to everyone, and who will bear the cost? And then what kind of ethical issues might raise, and what steps might help to mitigate potential security and privacy risks associated to like acquisition of brain signals, and like later on, like in later stages.
Yes, I think there's a very important point that you mentioned about the consent, because this is something that we have observed even with the online web data that is happening at the moment. There are several giant companies, internet companies, which sell our data without our consent. So I think it's the same thing again playing up in the brain computer interface as well. So I think we can definitely extend this conversation in the future episodes. I'd be really happy to host you again. So yeah, Sonal, as we are approaching the end of the episode, as we have this podcast especially focused for the research scholars, so I would like to know, what message would you like to give to the future generations stepping into this field of research and technology? Because I think it's both science and technology, but I would prefer to call it as research and technology. So yeah, please feel free to tell it from your perspective. What is your message?
Okay, this message would not just be for like, people working in artistic domains or policymakers or technology. In general, like as you mentioned, researchers, I would say like create your own hypothesis, perform experiments, collect data, and get your conclusions. If you cannot collect data, this generation is moving towards having humongous amount of open source data, and work with them, see how you can contribute and sort of close the gaps. And if you're working with algorithms, maybe you can see how you can sort of understand data before feeding it into algorithms. So yeah, to conclude, I would say connect the dots and be as creative as possible.
Thank you very much, Sonal. It was great speaking with you. And I hope we connect again for the future episodes, because there are a lot of pointers that have popped up in this episode. And I'd be really happy to extend this conversation again. Thank you very much.
Thanks, Omkar. It was a pleasure being here.